Hey, welcome everyone to the Azure Community Conference. This session is about never missing the bus using some cool feature in Azure Function, using an external service like IFTTT then that, and also Azure SQL. I'm Davide Mauri, I'm an Azure SQL PM in the Azure SQL engineering team, and I've been an MVP for 12 years. Then I did some consulting, or some for 20 years almost, and then I joined the Azure SQL group 1 year, a little bit more ago. But I'm still a developer at heart, so I really love developing and creating solutions like the one I'm going to share with you. And my specific focus is Azure SQL, of course, hyperscale developers, and everything you can actually do with Azure SQL. You can find all the resources where you can find me live or online. On this slide here, I blog a lot. I also usually very present in the community with sessions and conferences like this one. And I also recently co-wrote a book with a bunch of colleagues. It's called Practical SQL Database for Modern Developers, and I really recommend you to get that if you are a developer or you want to be a developer, and no matter what language you're using, .NET, Python, Ruby, it's all good. It's all good. We love everyone. This book is specifically taught for developers, written by developers, to make sure that by reading this book, you get all the information needed to start to use Azure SQL correctly and use the amazing amount of feature that Azure SQL provides. And if you know how to use that feature, I'm pretty sure you can have a easier life as a developer at least, because there's so much Azure SQL can do for you to simplify your code and maintenance that you really want to take advantage of it. This session is an example because I will be discussing of GeoSpatial functions and support. And of course, we have a specific chapter on GeoSpatial function and support in this book, so make sure to check it out. Now let's move to the topic of this session. And the topic comes from a real world that at some point I had to solve, just to simplify a little bit my life. So the challenge was that at some point I needed to figure a clever way to make sure I get out of the office right on time, to be sure not to lose my bus when, before COVID times when we could still go to office, because the office from the Microsoft Office where I work to my home is only every 30 minutes. So if you lose one, it's kind of, you have to wait a while to get and to catch the next one. So I really wanted to make sure that I never miss a bus. So I started looking at application, and many of the application try to give you some information on where the bus is and where it's predicted to reach your bus stop, but actually I discovered at least here in Seattle, they are not especially precise because of the traffic that varies, wildly on a daily basis. So what I really wanted to do is see if there is a way to hook into the public information that, for example, Google used to show where the bus is on a map, and create a geofence or create some notification so that when the bus enter a specific area that I know that is close to me, I know that when the bus enter that specific area, I have to go to the office, because on average, if I leave the office when the bus is there, I have like 99% chance to catch the bus on time. So I started looking at how I could do this, and I found that there is a very nice initiative where a lot of companies in public transportation companies are also contributing, that is called the GTFS, where basically you have public transportation data available in real time. So you just have to hook into the system, which is free, download the data, or actually keep downloading the data that is being streamed, so that you can actually access the bus, the information that you are interested into for your area, for example, in real time. And given that it's in real time, then you create this, you can create this solution that I was discussing. And I was super happy to see that the King County metro supports this option. Actually, I learned of this general transit feed specification by surfing the King County website. And so this means that I can access real-time information of my local public transportation and use it to build whatever I want. So there are just 8 steps to actually solve this problem. So the first one is, of course, hook into the real-time feed. And then, of course, I want to filter only the routes I'm interested in. I don't want to monitor all the routes, right? And then I want to store data somewhere, also to be able maybe to display on a screen or to do some analysis on it. And then I have to create a geofence, which is actually a perimeter where I want to be notified if the bus enter or exit that perimeter. And then, of course, check if the bus is entering or leaving this geofence I've created. If that is happening, I want to send a notification to my phone. And how do I do that? Well, for example, one free option is using a service called If This Then That. That basically is just an HTTP REST call that I can easily do. And that's it, because if I build that, I know that when I receive my notification, I just have to, leave the office, go to the bus stop, and just wait for the bus, because it will be coming in a few minutes. And you know what? It works perfectly. So I want to share with you how I built this solution, what are the tools I used, and how I used Azure SQL to actually simplify a lot, and I tell you a lot, all the work that I would have had to do otherwise. And that's it. So maybe you can do the same with your local bus transportation. Now, the problem with the GeoSpatial data is that it's amazingly interesting, but also, I wouldn't say complex, but definitely is not easy. It's not easy because the Earth is spheroid, and so you cannot just use, the Pythagorean theorem to calculate distances or check if something is within something else or calculate, other intersection, for example. So you need to do some, again, not super complex, but yet not trivial trigonometry to do this calculation. And it turns out that luckily, Azure SQL already has all these capabilities inside the engine for us. So if I decide to use Azure SQL as my database to store my data for free, I already have all these capabilities that are just there to be used. So I started looking at how Azure SQL implements the geospatial support, and it turns out that it implements in a very standard way. There is an entity called Open GeoSpatial Consortium that makes sure that all application that wants to use GeoSpatial data do it in a standard way, so it's easy to collaborate and cooperate between different solutions, and Azure SQL 100% supports that. It provides me with 2 data types, geometry or geography. Geometry is for small places where you don't really care about the roundness of the Earth. But geography is exactly what I want to use instead, because it allows me to store data in latitude and longitude, so I can just take the information that I'm receiving from the feed, store it into Azure SQL, write down how and define where is my geofence by literally drawing a polygon, and then asking Azure SQL to check if any point of the one I received in real time is actually inside or coming inside or going outside that polygon, which basically becomes my geofence. And I can do that pretty easily, as I will show you. And also I can have additional features like indexing and all this kind of stuff that will help me to make my solution scalable and performant. Now, everything I've just said is available as an example for you to download. You see the URL on the screen right now, and if you want, you can just go download download the code right now and follow me while I'm showing you and explaining how the code works. That's it for the session, or at least for the slide part of the session. Let's move to coding now. So this is the repository you can clone, and that contains all the code that you need to implement the solution. So before taking a look at the code, let's start to get familiar with the feed that contains the public transportation data. So here you will have all the links that you want to probably to use to get more understanding on this GTFS feed. And here I'm using, as said, the king country metro information. So let's go here. And first of all, the feed, we are using the real-time feed. So you can click on the real time, and here you will see this is the description of the JSON document that you will receive. And as you can see, there is a header and there is other information. Of course, we are interested in many of these, but the most important one is the vehicle position. And the vehicle position is something that will give us the latitude and longitude, among other stuff, if they are provided by the public transportation company that you are using to get the data. Now, if I move to the King County Metro Public Transportation Company, I can see here under developer resources that they are providing this feed, and I can just go here, and what I'm interested in is in the vehicle position. There are several, this is the protocol buffer, JSON, and enhanced JSON. I will go on and use the enhanced JSON that contains even more information. Just to avoid any time downloading it, I already have it here. And as you can see, there is this header and the entity as described exactly here. And then under entity, we will have the vehicle position. Here we go, here we go. So all we have to do is to download this feed. I would say map to us classes of POCO objects, so it will be easier to manipulate. And then I would probably save this data, latitude and longitude, and then the vehicle data, and then direction and trip information into the database. Now, why I need to do that? Because honestly, this route ID, I don't really know what it means. But if we download the static GTSF feed, here you will have the description that will tell you that specific ID to which route is connected to. So for example, I already downloaded this file here, and actually this is not something I can share. You can just download it from the King Metro website or from your provider. But basically is just this file. So you'll have a route ID and basically the bus number, and specifically I'm interested in this one. This is the one I would use to go back and forth from work. So I will use this ID to make sure that I will filter only the bus I'm interested into. Now to do that, first of all, we need to start to set up a database. And my database is I already set it up, and is this one, catch the bus. And as you can see, I have created several tables. Routes is the one that contains the route data that I imported. And here we go. So I'm interested in the 221. So that's the route I want to monitor. And in fact, in the monitor route table I created, there is only one route, this one, right? Now, just a couple of things here. How you can import that data into your table from a file. It's pretty easy. It's pretty easy. You can probably, there are several ways. You can, there is a tool here on the Management Studio that you can just right click and here you can do task and import flat file. But if you don't want to do that, because maybe you don't want to use tools to do this import and export because you have to schedule it maybe, what you want to do is just put this file, the root, and also a file I've already prepared for you in the database called roots.fm. So a file that describes how the root file is shaped in terms of data. So we know it contains an ID, an agency ID, short name, and everything. Everything is actually something you can infer from this file here. If you go here and root, you will see that's exactly all the information that are inside this file. So you need to use you need to create this format file, but I have already created that for you. And then what you can do is just store it somewhere in a blob store. For example, I stored in a blob store called Transit, if I remember correctly. And then use bulk insert right from T-SQL to import the data. So this is where I stored my file. Transit, here I just imported everything, but actually I'm just using roots and roots format. Now, what you need to do in order to import file is go to the container that you want to allow Azure SQL to have access to, and then here, get a shared access signature to make sure that you will allow Azure SQL to access the data. So once you do that, it will create a signature that is, as you can see, valid for 1 day. You do create, you take the query string, just make sure you don't take the question mark. And then you have here a file that will help you to do that. So that will be your shared access signature. So you need to create a master key in your database, then make sure that you provide the access signature, shared access signature for the blob you need to use. And then you just have to create an external source that will point to your blob, and then you just insert everything into the table, and that's it. That will work easily. And at the end of the day, at the end of the execution, you will have all the root data imported in the table. Then you can start to use it. Once you have, now that you know how you can import data, let's just take a look at the database and the objects I created. So I created a table called bus data, where here we have the geography data type that contains the location of the bus. And then I also have created an index, as you can see, a special index to sustain queries. And then I have created my geofence, again, using a geography as a way to store geographical data. And some other table that we will see later, but basically a geofence log that will contain when my geofence has been activated. So when a bus entered or exit the geofence, when the geofence was active. This is useful to calculate if a bus is entering or leaving the geofence, and that's it basically. Actually, let me do something. Let me create everything from scratch. Right, so we can just go on together and make sure database is completely clean. Now all I need to do is again import my data, so I can also show you. I already have created this, so all I have to do is import my data, and yeah, that's not needed since I just recreate the database. Perfect. That's it. That's exactly what you should do in your database. So create everything, import the data, and now we can start to play a little bit with some geographical data. So for example, of course, I want to monitor the educational route, and I discovered the educational route is this ID. So I will insert into my monitor route the correct ID. And then here you can see how I can create, for example, a polygon, which is actually a geofence, right? So this is the name I want to give to this geofence, and this is the definition of the polygon. This definition is using something called well-known text format that has been created by the Open GeoSpatial Consortium, so that I'm absolutely sure that if I use this format, I can copy and paste this string to any tool that support the GeoSpatial Consortium well-known text format and use it in the tool. So for example, there is a very nice tool here, and let me open it for you. Here we go. This is another GitHub website that you can download and just to learn how to create something like that. So let me clear everything here, and what I'm doing right now is taking this polygon, right, and copying and pasting it here, and then plotting the shape. That's exactly the geofence I've created, because when the bus stops at these stops, and I just want to make sure to catch the bus whenever it is in this polygon, which contains the bus stop, I want to be notified, because I know that when the bus leaves this area, since I actually work somewhere around here actually. Yeah, this is where building 44 where I work is located. I need to leave this building, take this road, and if I walk fast enough, I will catch the bus that will actually stops here. So I just noticed that when the bus is here, usually takes several minutes, and with my pace I can just go out to the office and take the bus with no issues. So that's it. Now you can also use this tool. Let's say you want to create another geofence. Let's say you are interested in putting a geofence here. You can actually create a polygon, and let's say you want to create a geofence here, and then that's it. You will be able to create that polygon. Now, and there is only one thing you have to keep in mind. When you create your polygon, for Azure SQL, since Azure SQL allows you to represent the whole Earth, you need to make sure that when you create your polygon, you specify the point in a counterclockwise order. Because by specifying the counterclockwise order, it's like you are walking on the perimeter, keeping your left hand or left arm inside the polygon, right? So this allows Azure SQL to understand that you are, with these 4 lines, you're representing the inside and not the outside, right? Because on a sphere, what does it mean to draw a polygon? Do you want to take the internal part of the polygon or everything else, right? So now I can take this, for example, and I can go here, and let's now do something very simple. Let's do declare, and then let's call it geography equal, and I can do geography parse, for example, and I can specify that, and that's it. So now I can do select G, and if I'm doing it from the Management Studio, I will also be able to see that my polygon has been correctly represented also in Azure SQL. So that's perfect, because this means I can add my polygon into my geofence. So I have sorted the fact that I want to monitor that route, and that I want also to create that geofence. So the data is, at least the static data, the data I need to create my monitoring solution is now there. Now let's move back to C# code and see what we have to do in order to start to use it. So the first thing is that I have created an Azure function here to create a serverless solution. So I have used the function or func init option to start to create the environment for my function to work. And just remember to download the Azure Function core tools in order to have func command available on your machine. And that's it basically, because the function init tool will create everything you need to have function working. Then you probably want to add a specific function. So I added the catch the bus function, and actually this contains 2 functions. One, let's start with the first one. One is get bus data. It's a timer trigger based function, which means that every 15 seconds this function will be called for me, and it will create a bus data manager class and will do the process bus data, which means it will go get the real-time feed, do some processing, store data into Azure SQL, check if a geofence has been enabled or not, and then that's it. And then I also have created another function called show bus data, that this is actually a REST endpoint, so it's an HTTP trigger that will be called when someone call HTTP endpoint that the function will expose for me, and we'll do a get method over that endpoint. And we will return, in this case, the last 50 point of the closest bus to our geofence. So I can go on a map and see where the bus is, and not all the buses, but just the one that is the line that I need to monitor, and also, which is the one closest to my geofence, because anytime during the day there could be more than one bus for the same line, right? So there are, I think, 3 or 4 buses that goes back and forth on the same line here. And I just want to make sure that I monitor the closest one to my geofence. Okay, perfect. Now let's take a look at the bus manager class, which is actually here. And so let's just get started with the usual stuff. So when I create the class, I immediately start to download the bus data and get the monitored routes in an asynchronous and parallel way. Get monitored routes is nothing more than just calling a select on this via store procedure that I have created exactly with this purpose in mind. So this one, get monitored routes. And the other one, more interesting, is download bus data. Download bus data is doing a get over the real-time feed that I've shown you before, making sure that we actually downloaded it correctly, reading the data, and then deserializing into a class I've created that just basically represent the whole feed. So let's take a look at the feed class here. And as you can see, I have the feed with a header and the entities, and the entity contains the vehicle, and the vehicle contains the position, and the position is actually latitude and longitude. That's perfect. So very easy for us to manipulate data now, because it's not more a JSON, it's a C# object. So what I can do once I have that C# object is starting to find all the routes that has been sent to me from within the real-time feed that are actually related only to the route I want to monitor, right? So here I'm just saying, okay, just find all the buses that are on the route I want to monitor. Once I have that, I will start to process the geofence, which will do something like that. We'll extract the information I need from the entity that I received and I have filtered, and create a simpler object that I will use to pass as JSON to Azure SQL. And in fact, here I will actually take advantage of the fact that Azure SQL can support JSON option, JSON parameters, so that I can pass this bunch of data without having to create many parameters in my storage procedure. Actually, let me show you the procedure. It's very easy. Or actually, it's not that easy, but at least the first part is easy. So let's do that. This is the procedure that then we will take a look together, but basically this is expecting this JSON. So it's very nice to have JSON support in Azure SQL, because instead of creating many parameters, one for each property I want to pass to the procedure, I can just create JSON. And this will also allow me, if I need to, let's say, add a new parameter here, like direction, like speed, for example. Let's say at some point I want to add the speed. I can easily do that without having to actually add a new parameter to my procedure, and so this means less code for me to write. So this is the JSON I will send to my procedure as a parameter. So the first thing I'm going to do in the storage procedure is checking that the sent JSON is actually JSON, and then I will immediately extract the JSON using the OpenJSON function and save it into the bus data. Now, it's probably easier to see that in action, because as you can see, the code here, it's very, very easy. I just created the parameter, call add bus data, and the result will be the active geofences, if there is any bus entering or leaving the geofence. So the code here, it's very, very basic, trivial, I would say, because it's nothing more than just calling a storage procedure and processing the results. That's it. So let's see the data. Let's see this in action, and then we can see then how I can actually calculate the geofences and everything right in Azure SQL. So let me start the function by, first of all, I need to start the Azure Storage emulator. This is something you have to do manually if you're not using Visual Studio 2019. So let me start the emulator. And of course, I already configured my settings to make sure that the Azure function connect to my database. And so all I have to do here is funct start, and that will start my function. Perfect. Now you will see that there will be two functions here running as soon as this gets started. Yeah, exactly. So the trigger that is timer based and the show bus data. So every 15 seconds you will see get bus data called. And here we go. This is the first one. So get bus data has been executed. There are two buses right now in this moment going back and forth on the route 221. And there is no buses in the geofence. Now let's see what, and as you can see now that after 50 seconds passed, now I'm reading and receiving the feed again. Now let's see and take a look at the content of the bus data table right now. So bus data, here we go. And as you can see, now we have the location. Now, the location here is shown in binary format because the geography data type is actually a .NET data type. So if you don't specify any specific methods to be rendered to transform the content into something that is human understandable, you will just see the binary. But it's very easy. You can just do like location dot to string, and then you will be able to see what is called as the, as said, the well-known text format. So these are the point, latitude and longitude and latitude to be correct, that represents my bus somewhere here. And actually there are two buses as you can see. So one is moving to Education Hill and the other one is moving from Education Hill. Now it will be nice to be able to see these buses on a map, right? Now, I can do that. For example, I would be able to take this, go to the map here, do something like that, plot shape, and here we go. This is our bus. Now, it will be nice if I could do that automatically. And actually, it is possible because the client that you see right now is something I use it as a starting point to create a very nice and simple, honestly, client tool to visualize on a map using the OpenStreet library the data that are stored inside Azure SQL. So what you have to do here is, first of all, if you're using a Visual Studio Code, just make sure that you have downloaded the live server extension, right? And now after that, just go on client, right click on client HTML and open with live server. This will actually serve that page for you. And here we go. So you will see that since I just started and the database was completely clean, you will see that the closest bus that is going towards the geofence that is somewhere here, is this one. And I just recorded 5 points right now. If I refresh, probably there will be a new one, as you can see. So these are the last 50 points that I have recorded for the bus that is closest to my geofences, is moving toward the geofence, right? So that's pretty cool. In basically almost no code, because again, let's take a look. This is just JavaScript code that you would have created no matter what. I mean, you could have used another database, you could even not use a database at all. So this is just client code that I have created just to show the map. But the real code is here. And the code that it's running actually is just reading the data from HTTP GET request that download the feed data and storing everything into Azure SQL. So the C# code is very simple. And now let's instead go and see how the storage procedure will work inside. And for example, let's see how we can understand if something is within something else, right? If my bus is within the geofence. So to do that, we can use this nice method, stcontain. So st means it's a standard method. So this is a method provided by the GeoSpatial consortium. So all databases, every tool that is adherent to the Open GeoSpatial consortium will have that method. So for example, Postgres will have it. So what you can do is on your geofence, so let's for example select from dbo.geofence, where so the geofence contains a field called geofence, right? So where the geofence contains what? This should be a point. So let's define a point. Let's do declare p. This will be a geography equal geography. We basically do what we did before, but this time let's go here to this nice tool, and let's take a point. For example, let's take a point here that I know it's well outside my geofence, right? Let's go back here. Let's parse the point. And now let's ask if the geofence contained that point. No, so this point is not contained in the geofence, even because remember the geofence. So the geofence is, and let's do also this to visualize the geofence in a well-known text format. So the geofence is here. Nice. So if I take this point instead, so this one, in that case, I would expect my point to be in the geofence. Now, let's see if Azure SQL is good enough to recognize that. So is that point inside the geofence? Yes. So by using the stcontains, we are just asking Azure SQL to use the GeoSpatial engine embedded in the query processor to understand if one point is contained within the area of a polygon, which basically is, are my bus in the geofence I have set up? That's exactly what Azure SQL is answering for us. So with this knowledge, what we can do is after we load the data into the table, we can start to find if any of the new data that we inserted into the table is within the geofence. If yes, then we will store the result into a temporary table. And here I'm using temporary table just to make easier for you to follow all the steps. In theory, you could probably completely avoid the usage of temporary table, but that's very good to understand, how all the data is transformed across all these passages. So we store the buses that are within a geofence into a temporary table. And then what we have to do is understand if the if the bus is entering the geofence, is leaving the geofence, or is just staying in the geofence, because probably we want to be notified only when the bus enter or exit the geofence. Now, to know that, we need to understand if the polygon already had that point previously. So we are checking right now if the bus is in the geofence. So what we have to ask to ourselves is, was the bus already in the geofence before? Because if it was, then it didn't enter the geofence. And since it was already in the geofence before, and it's now again in the geofence, this means that it's just in the geofence. It didn't move in or out. If we see that the bus is now in the geofence, but before wasn't, then we know that the bus entered the geofence. If we see now that the bus is outside the geofence, but before was in the geofence, then we know that the bus is leaving the geofence. It's pretty easy. So it's just checking the current value against the previous one, right? And to do that is actually a join, because we can store the previous value or the last known value into a table called, for example, and I created just as an example, a temporal table called Geofence Active, where we store all the buses that are now, at this moment, inside the geofence. This will help us to understand if, when I'm looking at the geofence right now, the last known value, which is basically what this table contains, already contain that bus or not. And this is a temporal table, so this means that every time we insert a row here or delete a row here, the history is kept for us. So I can do, for example, exactly this, for system time all, which means return even the past data, not only the current one. And as you can see right now, one bus for a short period of time was in the geofence. So at some point entered the geofence and left the geofence. Now let's see when. Since the Geofence Active only contains information on the bus when is in the geofence, I also decided to record in a log all the information about buses entering or exiting the geofence, so it will be easier to analyze, for example, in future. So that's why I created this geofence log. And as you can see here, while talking, I had several interesting buses going in and out the geofence. So this bus here, and actually let me order by ID descending. So the bus entered the geofence, stayed at some point, and stayed within the geofence for a while, probably to load and unload people, and then exited. And then another vehicle, the same vehicle entered and exited the geofence again. Now that seems strange to me, but it could be that there are some glitches sometimes in the received GPS data, right? But let's take a look. This is good because we can use the client we created to just see the data ourselves. So let's see what happened. Okay, so here we go. So you see that here we have a couple of different points. So probably this is where the buses started to enter the geofence, and then the other point was probably a little bit less precise than the first one, and then was dimmed out of the geofence. Not big deal. I mean, this doesn't aim to be 100% precise. The goal of this is to make sure that I have received a message, so that when the bus left the geofence or entered the geofence, I could be notified and make sure that I leave the office. You see the bus is now staying within the geofence. So, but as you can see, this is working very nicely because we now have our data, and this is all available here, and that's it. That's pretty easy. I am solving the problem of understanding the geographical intersection of two polygons, or a polygon and a point, just allowing Azure SQL to do the heavy work for me. I'm using contains here, and that's it, because then I store my data in a table, do a full join to understand if a bus is entering or exiting the geofence, and then just again, as said before, I'm just logging everything. And then of course I need to return the active geofence to my application, so that when my application receives the result of this procedure, can try to send data to if this and that, a service I have created just to notify my phone. And in the if this then that, I've created this catch the bus, where you basically create a webhook that listen for someone to call a specific webhook. And when the webhook is called, in this case by my Azure function, I'm triggering a notification. And this means that I have a notification on my phone. And then I know I have to leave the office and go and catch the bus. So that's it. As you can see, it's very easy, and even this is working. Actually, here, if we take a look at the log, you will see that at some point the if this then that web service has been called, because there was some data that was showing that the bus was in the geofence, but that's basically it. So a very simple solution where you are taking advantage of Azure SQL to do all the complex calculation on the earth, and what you have really to do is read a feed, convert that feed into a POC object, manipulate the POC object to filter out the buses you are interested into, take the result of that filter, send it to Azure SQL, use the stcontains function to check which buses you just have received are actually inside the geofence, understand if the bus that is now in the geofence was even before in the geofence, or it just entered the geofence or left the geofence, and return that information to the function so that it can call if this then that. Very easy. Now, it's the beauty of this solution is that it's absolutely easy, and thanks to the fact that Azure SQL has the geospatial support for me, and I'm just taking advantage of it. And in addition to that, I'm also taking advantage of JSON support that Azure SQL has, and also the temporal table that allows me to exactly understand when a geofence was activated and whatnot. That's it. Code is pretty simple. Now let me stop this, and let me also show that you have Azure deploy script here that you need to run using Windows System on Linux. So you can do, once you have installed Windows System on Linux, you can just do deploy and deploy Azure. It will create for example, a resource group, define application name, create the function for you, deploy the function from GitHub. So the deployment will be done just by pushing everything on GitHub and cloning the repository right on the Azure function running on Azure, and that's it. So just start to use it. It's very fun. It's very interesting to see how easy some complex application otherwise could be created just putting together everything that Azure has to offer. That's all for me. I hope you enjoyed the session. If you have any question, feel free to send me an email or to create an issue on GitHub if you find something that doesn't work as expected, or maybe you want to contribute to the repository. And yeah, let me go and catch the bus now. Bye. Actually, before leaving, let me just remember you two important things. The first one is this website where we all are Azure SQL product group, at least the one that works on Azure SQL blogs. So make sure that you check out the article we release. There is a very nice article I pointed you if you are interested in Azure SQL right now, because there are many more features that we packed into Azure SQL. So what are the 10 reasons that I personally think you should use Azure SQL in your next project? So just make sure to check that out. But also, if you really like kind of a code first approach, we have created a huge amount of samples that you can just use to learn how to use Azure SQL with any language you want, that will cover all the features that I mentioned today and even more. So just go to doc.microsoft.com, click on code samples here, then make sure you filter by SQL database under the Azure product, and you will be able to find all the examples you may dream of, all with source code, with deployment option right on Azure, so you can just try them out and see them in action. So it's an amazing learning opportunity. Thank you again. Make sure you stay tuned for the other session. The one after me looks pretty interesting on Dapper. And again, thank you for attending. See you next time. Bye-bye.